What about velocity? How are we going to measure that? I mean, you were already saying that the velocity varies at different parts of the current. The outside of the bend is flowing faster than the inside of the bend. So how do we get as accurate a reading with that as possible? Well, what we need is a mandarin orange. And what you're going to do is measure out a 10-metre length of the river. And then you're going to time how long it takes for that mandarin orange to travel down those 10 metres. So let's have a wee look at this. I'm going to try this out and we'll see how this goes. Really what you need is a bunch of team members here. You'll have somebody up there at the start of the 10 metres dropping the orange in, somebody down there 10 metres further ready to catch it, so that our precious orange doesn't get wasted and you can reuse it, and somebody else with a stopwatch. Now, let me see how we're going to get on. There goes the river, or there goes the orange into the river, and you'll see as it gets caught up by the current what's going to happen to it. Is it travelling faster or slower than you anticipated? How long is it going to take? There's been picked up by the current at the outside of the bend, and it's travelling down here. Here we go. Here we go, it's going a bit faster current there, whoa, and boom, hits the side much faster. Now what can sometimes happen with these is they get kind of caught with little kind of eddies, little currents, or they can get caught behind a rock. This one seems to have a pretty clear run here. There it goes, still coming down here. It's slowed way down at this point because it's come away into the middle of the channel now, and it's going much slower. And what you would have, as I say, is somebody down at the other end of your 10-metre interval, ready to catch it, take it back out again, and see how it gets on. Now, here's my question for you. I don't think I'm going to be able to catch that. Goodbye, dear orange. You have served us well. Thank you for your service. I'm giving it a little salute. Well done, orange. Awesome. Go you. If I were to throw that in again, what are the chances are that it would have exactly the same journey and take exactly the same time? The chances are very slim, are they not? Let's see if we can follow this down a little bit more here. Still there, still going. In fact, oh, behind that rock, coming into the inside of the bend now, slowing way down. And this is one of the things that can happen sometimes. They can get stuck and caught in behind somewhere. In fact, that one has. I can still just about see it. There it is. It hasn't got caught, but much slower there, and it kind of can maybe get stuck. If I was really brave, I'd lie down there and try and rescue it, wouldn't I? But I don't need to. Why? I thought I hadn't brought another one. But it could get, oh look, it is. It's going to get stuck. And that's what can happen sometimes. I don't know if you can even see those little kind of whirlpools in the water there. I can see them. And there's the orange is actually caught in one going round and round. Actually going back upstream. Is it going to escape? It is! The orange is free. Here it comes. It has not been caught. It has managed to get away. And down it comes. Now there's a big challenge here with our little orange. Big challenge here because there's a few obstacles in the way. Will it make it through or will it not? What's going to happen to our orange? If it does make it through, it's about to go on the journey of a lifetime. Here we go. Will it make it up over that? Oh, just about, and away it goes. Goodbye. Oh, so close. So close. But now our orange is stuck. It was just about to go on this epic journey down that little bit, but it is caught behind there. Now, what that has shown us is the fact that depending on where the orange goes in the river, it will take different amounts of time. So similarly with what we did with the depth, we couldn't just take one measurement back here because that wouldn't have been accurate. We had to take a number of them and find the average. It's exactly the same with the velocity. We can't just take one go on this 10-metre section. We have got to take a series of them. And what you're going to do is do a series of 3 readings with this. It's why you've got to save the orange, because the jug feed department can't afford that many oranges for that many of you. Got to take a series of 3 of them on that journey, that 10-metre journey down the river, and then back up again, and you'll do a second one, and it'll take a slightly different route. It'll take a slightly different amount of time down there, and a third one again. and it'll take a slightly different route again, slightly different amount of time. And guess what you'll do once you've got your 3 readings? You'll calculate the average. And in calculating the average, then you're going to try and get a more accurate reading than you would have done if you had just taken one single reading. Now, this information that I've just given you on the data collection process isn't just important for, whenever you're out in the field work collecting your data. It's actually really important at the end of the process whenever we're evaluating our data as well, our data collection. Because I want you to think at this stage, which one of those 3 is going to produce the most accurate and reliable data? The width, where you just start there, and it's very easy to see where that is, and over to there, and it's very easy to see where that is, as long as your measuring tape is stretched out and is tight or taut, T-A-U-T, then there's not going to be much will go wrong with that one. Or depth. Well, you're taking a series of readings with the depth, so you're not just reliant on one, but you are missing bits out in between. So it is a sample, unlike the width. Or velocity. And you can see that there's lots of ways in which the velocity readings could end up becoming less accurate depending on where your Mandarin Orange goes. So which one of those is the most accurate data collection method? And therefore, which one is going to give you the most accurate results? And we'll pick up on that thought again whenever we come into the section on evaluation.